Good morning, everyone. I'm going to the Algebra 2 midterm review. This is day 2, or the second half of the concepts. This is 7a and 7b, and we are factoring a trinomial. So step 1 is always going to be to factor the c term. We have x squared plus 8x plus 12. 12 is 1 times 12, 2 times 6, or 3 times 4. Those are the factor pairs. We're going to check all the signs. If everything's positive, all factors are positive. If the c term is negative, you have one positive and one negative factor. If the c term is positive, you have two possibilities. Either both factors are positive or both factors are negative. Again, this is when the leading coefficient is 1. Okay, so we do trial and error, and we find that x plus 2, x plus 6 are the correct factors because 6 plus 2 sums up to the middle term, or the b term, of 8. Second example, x plus 7x, that should be x squared plus 7x plus 10, and you get 1 times 10, 2 times 5 are the factor pairs, and you get x plus 2 times x plus 5, sum up to 7, and that's problem number 7 solution. Let's go to number 8. This has to do with tire tracks, and you're given the formula that L equals, that's the length of the tire tracks in a skid, are equal to s squared over 252f, where s equals the speed and f is the friction coefficient. And again, that will depend upon the different weather conditions. If it's ice, it changes. If it's rain, it's going to change. Wet leaves, all those other types of environmental situations. So let's compare someone traveling 90 miles per hour versus 50 miles per hour. You would substitute 90 in for the speed. Square it, divided by 252f minus the second speed, which is 50 squared over 252f, for a final answer of 90 squared minus 50 squared over 252f. Again, so you can't lie and tell them how fast you're going because they can calculate it based on your skid marks. Okay, 8b, we have 100 miles per hour versus 70 miles per hour. You would square the 100 over 252f minus 70 squared over 252f for a final answer of 100 squared minus 70 squared over 252f. Okay, we're moving down to number 9, which asks us to simplify. And we have negative 3 over 5x times 10 over 11x squared. I apologize, in the example I sent you, the negative 3 I think somehow came off, but the numerator should be negative 3. So you multiply numerator times numerator, denominator times denominator, or you can cross cancel in the beginning, your choice. Negative 3 times 10 is negative 30 over 55. X times x is x squared, which simplifies to negative 6 over 11 x squared, because 30 and 55 both divide by 5. And you also, like I said, you could have reduced in the beginning. 9b is given negative 5 over 8x times 2 over 3x, and so you have negative 5 times 2 is negative 10, and 8 times 3 is 24, and x times x is x to the second. Again, that's going to reduce to negative 5 over 12x squared, and that is the solution to number 8. Please, while we're doing this, if you guys would please write your notes so that you can study for your exam. Okay, the next problem, let's go to 10 first. 10 is the graph. So this is people going out for a walk, and we're comparing, this is a rate chart, miles per hour. Okay, your x-axis is hours, your y-axis is miles. And what we're looking for is rate of change, guys. So you want to see where the slope is the steepest. So they start off going really, really slow. So maybe they're climbing up a mountain, they're really tired, something happens that first hour, and they only get to go a half of a mile in that 1 hour. That's really slow. And then from 1 hour to 2 hours, again, it's even slower. So we want to just look for the highest rate of change. And if you look from 2 to 3, you see a huge amount of distance has been covered in that time between the second and the third hour. Again, take a look at it. We go from a little less than 1 mile up to a little less than 4 miles. So in that hour, we have covered 3 miles. So they are moving at a steady pace. And lastly, from 3 to 4 hours, which would be here, there's only a very short distance traveled. The average person walks a 20-minute mile, so again, there's reasons they could be going slower. The correct answer should be between 2 and 3 hours is the steepest rate of change. Again, look for the steepest slope when you have a linear function. Going to number 11, we're doing inverses. Y equals 3x plus 11. You're going to swap y's and x's, just like we've done before. I know it's been a while. So what you want to do is x becomes y and y becomes x. So you get x equals 3y plus 11. You're going to subtract 11 from both sides using opposite operations. X minus 11 equals 3y, divide by 3, and you get x minus 11 over 3 equals y. Now you should be done, but we do want to put it into proper notation, which is f to the minus 1 of x, and let's read f inverse of x. Again, on the test, which I didn't do, I believe they leave it in the y equals format, but we should put it into the proper notation. Again, that's number 11. And we're going to go to the final question. Sorry for that, guys. Okay, number 11. We are again working from home due to this pandemic that we're in the midst of. Okay, that won't work for me. Okay, number 12 is an open-ended short response. Y equals 400 times 0.90 to the x power, where y represents the number of milligrams of ibuprofen in an adult body, where x equals the number of hours. So what do they want us to do? They want to know what is the original amount and how do you know? So let's use the formula that I like to give you guys, which is A, which is the value we call after everything has transpired. O is for original. We have 1 plus or minus r, where r is the rate of change in decimal form. And to the x power, sometimes we write that to the t power, because in many instances that will be time or the number of iterations every week, every day, whatever that is. Okay, so let's take a look at this. 400 is the original milligrams of ibuprofen, and it's clearly seen by its location. Again, please use structure to help you in your decision making. We have 1 minus 10 cents would yield the 90 cents. Remember, sorry guys. On your paper, it says 400 times 0.90x. I forgot to write that. So the 0.10 would be the rate of change, and since it's going down, 90 cents is less than $1. That is a decay or decreasing function to the x power. So answering question A, 400 milligrams is the original amount. I know this because of the location of the 400 in the formula. Is it an increasing or decreasing function? Well, if B, which is your growth or decay factor, is greater than 1, we have growth or increase. And if B, the value in the parentheses, is less than 1, we have decay or decreasing function. So again, we were given 90 cents is the the decay factor, which is less than 1, therefore it's decreasing. For question C, it says, what is the amount of change, or what is the rate of change? The rate of change is 10%. How do I know this? Because 90 cents is equal to $1 minus 0.10. Remember that when we do it in the decay factor, it's a decimal, but when we ask for the rate of change, we want to convert that back to percent. 0.10 becomes 10%. Question D, when will all the ibuprofen be out of the system? Now, you guys are going to have to work on this, and what you want to do is you just want to change the values of x until it's all gone, until you get a 0 number. It is decreasing. It might take 5 hours, 10 hours, 12 hours, 15 hours. Go ahead and use your calculators to do that. On the TI-84s, we like to put this into y equals second table and scroll down through our x hours until the y value is 0, or if it never gets to 0, you can get it to an incrementally small number, and I will accept that as your answer. Thank you so much, guys. Good luck on the exam later today. Have a great day. Sarah out.